In 1881, Joseph Boccabella, a Barcelona, Spain-based publisher and devotee of St. Joseph, bought a plot of land in the city's up-and-coming Eixample neighborhood to build a church devoted to the poor and St. Joseph. By 1883, a young Antoni Gaudi, already becoming famous for his architectural marvels, became the architect of the Temple of the Sagrada Familia. The design of the church is the embodiment of what Gaudi envisioned, with changes as required using modern construction techniques and materials. Gaudi considered the Sagrada Familia, which he worked on for 43 years until his death in 1926, his life's work. Traditional Gothic architecture at the time Gaudi was working used flying buttresses as functional load support, but Gaudi wanted to do something different with the Sagrada. His ornate and complex designs he considered beyond Gothic, but in fact the perfection of the Gothic. In 2026, 100 years after Gaudi's death, the church is still under construction. The Sagrada Familia Foundation serves as the owner, designer, and contractor on the church, hiring consultants as needed.
All those loads into the ground, they had to use flying buttresses. And this is something that Gaudi learned from that, but he went, let's say, beyond that system. So to provide really light in the inside, he used inclined columns, which actually they could transfer loads directly to the ground, so getting rid of these buttresses. So this allows to provide much more light in the inside through windows. But also the thing is that those inclined columns, they are, sometimes it's a bit difficult to understand, but they are kind of a bi-directional net of funicular polygons. And the thing is that they are meant to carry mainly compressive forces. So in the way that form is following forces. So this is one of the new geometry that Gaudi proposed, which they are called ruled surfaces, which they are made of straight lines. So by changing the endpoints of the surface, the curvature of the surface changes as well. And in this case is a hyperbolic paraboloids, whereas another, let's say, geometry of the same family, this is a hyperboloid, which actually you can see that there are two circles connected by strings, but if we shift one of the circles, we start to have a curvature, but the strings, they are still straight lines. So meaning that we can change the curvature, and also because they have straight lines, you can lay reinforcement if needed.
Steve McKechnie is project director for Arup, which was brought on to the project as a consultant to develop a solution to make sure that the continuing construction of the towers was structurally sound and able to withstand seismic and other risks.
The construction method they were using at the time was going to be too heavy, right? What they were doing, they were building reinforced concrete core with reinforcing bars and concrete faced with stone. So this ended up very thick. They were using the concrete as the structure and the stone, because it has to be a stone building, doesn't it? The total weight of the tower was going to be too much for the columns, which Gaudi built in his first project on the site in 1843, because the Tower of Mary is directly supported by the columns in the crypt, and the load was going to be too much for those columns. They couldn't do anything to strengthen them. So they were looking at ways to make the tower lighter. They imagined perhaps using a steel diagrid. Stone masonry is a construction form that has been used for thousands of years with good reason, because it is actually strong. And the tricky thing is that it needs dead load, it needs compression between the stones to make the whole thing work and to be strong. By using pre-stressing, we can put that force between the stones so that they can carry moment and they can carry shear, and they become like a structural material that we're used to using these days. So applying that to this, I think, was innovative. Is it totally unique? No. Is the thought of making a system which is assembled off site and comes to site and fitted together on site and fits together well, is that unique? Probably not, but it's relatively unusual. It takes quite a lot of care in the planning and the design of the pieces and the planning of the procurement, and it takes a collaborative approach throughout the whole supply chain. And because Sagrada Familia are sort of vertically integrated in that way, they're in control of everything, it enables that holistic thinking.
Mauricio Cortez is one of the architects of the central tower of Jesus Christ, the highest point of the church, which will be topped with a 17-meter tall cross.
So each module of the cross comes as complete and prefabricated as possible, also in terms of weight. So this lower arm came, each one of the pillars, in a separate truck and was pre-assembled here. Up next will be the glass frames and the glass itself, and as much as we can build on the interior, and then we lift it up